welcome aboard, my dear JEE warriors preparing for the year 2027 who are currently in class 12th. Class 12th has just started, and already you have started to feel that there are so many things that you missed. You wasted 11. Sir, I never knew that these concepts which you learn in 11th are so useful in 12th. And all those regrets, all those embarrassments are right now there with you, isn't it? Let me know quickly in the chat box. Somebody already saying, yes sir, 11th wasted. Hi Bunny, hi Tharun Kumar, hi Azad, hi Monish, hi Amruta, hi Hema. Good evening, my dear warriors. I hope I'm audible and visible to all of you. Hi. Yes, your capto is here. And because of all these regrets only, what happens is you start blaming yourself, you start blaming somebody, and your backlog starts piling up. And backlog means something what you should have done before, but you didn't do it on time for whatever reason, and now it is affecting your current plan, current preparation. And if you see specifically for physics, obviously the same applies for chemistry and maths also. When you start with first few chapters, you realize so many dependencies are there. In physics, when you start with electrostatics, the very first thing of vectors, then vector resolution, addition, then you talk about forces, Newton's laws, circular motion, so many concepts which are needed from class 11. And when you go to the later on part, you will see work power energy concepts, center of mass concepts, rotational motion concepts, simple harmonic motion concepts, all getting used everywhere. And that's where the first chapter only disappoints you, puts you down because of these dependencies. So that's why I have come over here to clear most of these dependencies and to make sure I give you a head start, a kick start for your 12th standard journey. Mechanics for class 12th, meaning this is not for class 11th, this is for class 12th. Mechanics is a class 11th topic. But I am going to teach you in the very different way. This is one of the most unique lecture which you're going to find on YouTube, I can assure you on that. Because I will keep in mind your class 12 students. I will keep in mind you have those backlogs. Exactly those things, whatever you will need, I will teach you that. I will not waste your time teaching everything in mechanics because not everything is right now needed. Later on, yes, for sure. But for your class 12 to be in continuity so that you don't fall back. If you have joined Lakshya batch, you should feel like, okay, I belong here. So that is the reason why I have come here to clear those things. All right. Okay. My name is Captain Shreyas. Yes, I am the physics teacher. I have been training, guiding for a long time now. It's almost 14 plus years. And I did my graduation from IIT Nagpur. I did my research from IIT Bombay. And I have been obviously on the online platforms for almost like 6 years now. Before that, offline for almost 6 years. So 6 to 7 years. So almost 13, 14 years I've been teaching now. Cool? Yeah. So let's begin. I know Sweta, 11th is wasted. 11th is wasted. Hello. Good evening. Yes, the legend is here, Monish. Thank you so much. And feeling quite devastated and demotivated. Okay. So shall we start with the problems of 11th and then move to the 12th? I will link everything. Okay. So I'll tell you how the planner for this today's backlogs is going to be, and that will help you understand this lecture content very nicely. I will go with vectors. I will go with basics of, kinematics, whatever is needed. Basics of kinematics, basics of vectors, Newton's laws of motion, all these concepts, whatever are needed basically for the chapter of electrostatics. For the chapter of electrostatics. For the chapter of electrostatics and Gauss law. Electrostatics and Gauss law. These chapters are going to need these concepts, so we'll touch upon them. If anything else is needed, that also we'll touch. Is example, for example, work energy. If we need work, power, energy also, we will touch on that. As many possible concepts we will touch upon today for helping you understand electrostatics, Gauss law, voltage, potential, all right, all these things. Ready for it? Okay, I am here always, Tarun, to help you no matter what. Okay, cool. Yes, SHM is also used in 12th. I know, we will deal with it separately. At once, if I go everywhere, then you will be like, sir, this only needs another backlog session. So don't worry, I will help you out with everything. SHM is not priority. See, SHM is used in 12th, but it's not like the utmost priority. This is the utmost priority. This is P0, highest priority order. After this only you can understand SHM and everything else. Okay, even if you leave those SHM questions for now, it's okay. SHM is important, but later on you can do it. SHM will be more useful when light waves will start, AC will start and all of that. So before that we will do backlog for that also. Okay, cool. So let's begin. Let's begin. Now what happens is we need vectors for even the definition of field, definition of force in electrostatics and even in gravitation. And you will notice gravitation has lot of similarity with electrostatics and Gauss law. So when you are studying this chapter, my advice to you is the chapter of gravitation from class 11th. You can study that as well with this. This is almost similar. Okay, you can cover this class 11th topic. This is your class 11th topic. Very similar concepts. Okay, if you have left it, then you can just complete it maybe within couple of weeks, next 2-3 weeks. Now let's start. See, we all know vector, a vector is a quantity which needs both magnitude and direction for its complete description. And the manner in which we represent a vector is always with a arrow mark, this one being the tail, this one being the head, and the head always points in the direction of the vector. The head always points in the direction of that vector. For example, force. If I say I'm applying a force with this arrow mark, means the force is applied in this direction. If I put the arrow mark like this, the force is applied in this direction. If I say the velocity is like this, that means I'm moving in this direction. If I say the acceleration is like this, that means it is accelerating in this direction. The length of this arrow represents the magnitude of it. The length of the arrow represents the magnitude of it. The magnitude of it. So we have magnitude represented by the length, direction given by the arrow mark, both of these things. And the way you represent the vectors is very simple. You can write, let's say for example, the tail alphabet is O, the head alphabet is A. You can give a simple symbol like A bar to denote that it is in the direction of A from O. So the vector OA bar can be also represented with a single alphabet A bar. But when I use two alphabets, necessarily the first alphabet has to be the tail, we know this, and necessarily this has to be the head. When there is a single alphabet, there is no head and tail denotion. But when we have two alphabets, 100% the first has to be the tail and the next one has to be the head. So that is how it goes. And if I am interested in the magnitude of it, we do like this, OA bar modulus, which is the same as A bar modulus. This is nothing but the magnitude. This is nothing but the magnitude of that particular vector. Is that right? These are the basics of vectors. And then we say that if I by chance happen to write AO bar, that is reverse. That means this is the tail, this is the head. That will be the negative of OA bar. This is the negative vector. This is exactly negative vector, meaning this is exactly opposite of that. So AO bar AO bar will be exactly like this. This will be AO bar. This will be AO bar. You can see this would be A, this would be O. Direction is opposite of that of the original vector. So this is also called as the negative vector. This is also called as the negative vector. Now, you represent those vectors in terms of something called as unit vectors. Now, these unit vectors are very special vectors. Unit or unity vectors. Unit vectors. These unit vectors are special vectors. Basically, they have a magnitude of 1. A magnitude of 1. So, for example, if I tell B bar modulus is 1, then I can conclude B bar is a unit vector. Similarly, if I say C bar modulus is 2.7, or even let's say it is 0.5, then I would say C bar is not an unit vector, for sure. But every time checking their magnitude and saying it is a unit vector, it is not a unit vector, is a painful process. So there is a special symbol for it, and the symbol for that is a cap. So if you put a cap instead, cap or a hat, whatever you want to call it, on the vector instead of a bar, that represents that it is a unit vector. Meaning, for example, if I say a cap, it is understood it has to be a unit vector. So a cap has to be an unit vector. No doubt about it. So if it is a unit vector, if somebody takes modulus of that, it will be 1. Undoubtedly non-negotiable. So if somebody says Z cap, 100% it is a unit vector, the magnitude will be 1. And when I say magnitude is 1, it means if I show that vector, let's say this is a cap, this length is exactly 1. It could be 1 centimeter, it could be 1 Newton, it could be 1 meter, it could be 1 kilometer, but it is 1 in some units. What that units are doesn't matter, but it is having a value of 1. Is that clear till this point? Everybody? Okay. Yes, I'm going to help you with all the important concepts for class 12 syllabus first 2 chapters, which is useful. This is a dependency class for class 12. Please understand that. It's not entire 11th. It's not entire 12th. It's a dependency, which is the most unique class. I think I can almost guarantee I have not seen across such a lecture anywhere on YouTube, because everybody does entire 11th, which is again waste. Everybody starts off with 12th without teaching. So the 12th standard students suffer, and they keep this suffering deep inside their heart, in their mind for a long time. So this is the first time I feel, I don't think even Hindi channels have this. On English channel we are doing it. Just imagine. Yeah. Sir, but the magnitude will be same, right? Even if the direction is opposite? Yes, in the previous question, yes, the magnitude will be same. So even though this is a negative vector, yes, I can definitely say AO bar modulus will be equal to OA bar modulus. Yes, 100%. The magnitudes will be same. Mod will be same, but directions are opposite for sure. Now, the manner in which I define this unit vector, where it is 1, I can also find a unit vector if another vector is given, and I'll explain that to you. But before that, the special unit vectors which we have, let's say these are the y, z and x axis, the standard x, y and z. Then if I have any random vector, okay, it could be any random vector, let's say v bar, then any vector in any 3D, 2D, 1D direction will have something in X, something in Y, something in Z. That something means a component. So, for example, I will explain this to you in a beautiful manner. See, there is a Pandu. There is a Pandu. Pandu is walking on a railway track. He is walking on a railway track. And there are those milestones, 2 kilometers, 3 kilometers, 100 kilometers, 5 kilometers, whatever. So Pandu can call somebody, hey, I am on a railway track, I am on the 5 kilometer mark. Hey, I am on the railway track, I am 7 kilometers from the station. So that is like a one-dimensional motion. You can easily predict where the Pandu is if I tell you what milepost, what kilometer mark he is. But imagine Pandu is on an open playground, vast Sahara desert or big ice lake. So Pandu might go like this. Pandu might be here. So Pandu is somewhat in some east direction, somewhat in the north direction. So from the original position wherever Pandu is right now, maybe Pandu might say, hey, listen, if you want to find me, go travel 7-8 kilometers in the east direction, then travel 3-4 kilometers in the north direction, you will find me. So you need something in X, something in Y, something in east, something in north in order to locate the position. But let's say Pandu drank Red Bull. When you drink Red Bull, what happens? You get wings. Please don't drink Red Bull, guys, it's not safe. So you drank Red Bull, Pandu got wings. This is Pandu with wings. Pandu with wings. Pandu drank Red Bull. So Pandu will say, listen bro, if you want to find me, then do one thing, go east 3 kilometers, then go south 5 kilometers, then fly up, you will find me. So in order to locate him, because now he's in a 3-dimensional motion, he has got wings, he will give me 3 parameters to find his location. Are you getting it, my dear warriors? Yeah? Yeah. All right. So why magnitude can't be negative? Magnitude is value. It's a mod. Modulus is always positive. Magnitude, if it is negative, then that negative sign gives me the direction. So magnitude should never contain directional information. So it will not have negative sign. Because the moment in mathematics plus minus comes, minus means opposite of something, and when you are referring to the word opposite, it is also directional information. So no directional information can be there in a magnitude. So that's why it is a positive value always. Okay, PW student? Okay. Now did you understand what is the meaning of this something in X, something in Y, something in Z? So they will have these somethings are called components, and that's why we say, okay, this vector has something which is some component in X, some component in Y, and some component in Z. Now I'll tell you the funny thing about these components. Okay, I'll tell you the funny thing about these components. Let me just get rid of this original thing. So a vector, it is called a vector, can be split, and this process of can be split is called as resolution. So when they say you have to resolve a vector, that means you have to split a vector. You have to break the vector into its components. Can be split into components, and component means what? Parts into parts along x, y, z, along x, y and z axis. So the funny part about these components is that I'm pretty sure many of you might not have even known this. So if I construct an imaginary cube, let me construct an imaginary cube out here. It's little crazy, but I will try my best. Okay, I will construct an imaginary cube out here. Okay, there we go, like this, okay, one sec, like this, and like this, and like this. Now, see if you can get a feel of this imaginary cube. Just visualize the room in which you are sitting to be that cuboid. Okay, it's not a cube, it's a cuboid actually. So, if I draw a diagonal inside that cuboid, Just imagine that room which you are sitting, from one corner at the bottom to the opposite corner on the top. Imagine a diagonal which is passing through the center of the cuboid. Okay, that is exactly your vector, guys. That is your vector, and that vector has some breadth, length, and some height, which is the component of it. So to reach there from this bottom corner to the top corner, you are giving the information, hey, listen, you want to find me, go somewhat in east, go somewhat in south, and then climb up, you will reach me. So those some things are those components, length, breadth, and the height. Are you able to visualize this? Are you able to visualize this? Yes. Oh, in the ad they say if you drink that, you will reach heaven. Oh, that means you fly so high. Oh, too dangerous. Okay, great. So I can say my vector is actually made of three things. This component, this part, this much in x, I will call it Vx. This much in y, I will call it Vy. And this much in z, I will call it Vz. So this will be Vx and Vy and Vz all combined together. So the combination of the components gives me this original vector, gives me back the original vector as a resultant. As a resultant. Resultant means what? As a result, like your final result, maths, physics, chemistry combined together. So think of this as maths, physics, chemistry, biology, English, blah, 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 blah. All of them combined together. This is your resultant, combined quantity. I am pushing, somebody else is pushing, somebody else is also pushing. Together, how much is your togetherness as a push? That is your resultant, net, effective. Getting the feeling of the word resultant, guys? That is the meaning of the resultant. So you combine them together, you get this. If Vx was different, then my result will be different. Like my math score is different, my result will be different. If my English score is different, my result will be different. Getting my point, everyone? So I can now write this vector as, there are these special vectors in x, y, and z. Ooh. And z, unit vectors. Those unit vectors are called I cap, j cap, and k cap. What are they called? I cap, j cap, and k cap. These are three special vectors. The speciality is I will be always in x, j will be always in y, k will be always in z. The magnitude of them will always be 1. Okay, so I cap magnitude, because I put a cap, it has to be, no option at all, non-negotiable. The magnitude will be 1. This will be along x, this will be along y, this will be along z. So what I can do, I can think like this. This vector Vx, I cap is 1. Let's say Vx was 7 units. This entire length is 7. So if I take I cap 7 times, I will get Vx bar. Are you getting my point? For example, this is 7 in length. This cuboid's length or breadth, whatever you want to call it, this is 7 units. So if I take a unity vector, I put it 7 times, I will get that entire length of Vx bar. So that is why I can mention this Vx bar as, you take the length of it, I don't put bar, and you keep it I cap times, or you take the I cap and multiply it 7 times, 6 times, whatever that is. This is the value of the component. This is the actual component bar. It's a vector. This is the value. This is the value of it. If you do not get it, no issues. I will explain that to you. Say for example, I tell my Vx bar is 6 times of I cap. It means if I go on the x-axis, and I know I cap means along the x-axis like this, correct? So if I put I cap 6 times, 1, 2, 3, then 4, then 5, then 6. This entire thing is then Vx bar. And this number 6 is just Vx, just the value, the magnitude of it. Think of it like that. Are you getting my point? Yeah. So 6 I cap. So I cap put 6 times, that will give me Vx bar. That's what I'm getting. Same way, my Vy bar, if I take j cap, j cap, j cap, j cap, how many times? Whatever is the value of Vy. Maybe Vy, the length, the height of this cuboid is 4. So j cap, j cap, j cap, j cap 4 times. So this will be nothing but Vy times of j cap. Vy times of j cap. Similarly, can you guys think my entire z component will be k cap, k cap, k cap. How many times? Vz times Vz can be 700, 500, whatever. So you have to put k cap that many times to get the total vector of Vz bar. So I'll just put k cap over here, and yes, it will be Vz times. No bar in this case because this contains the direction. So any vector you will notice it has a magnitude information, direction information, magnitude, direction, magnitude, direction. So like over here, 6 is a scalar number, I cap is a vector, and when magnitude and direction both come together, you get the complete vector. Can you see this amazing thing? So Vx over here is nothing but the magnitude. I cap has no magnitude, it is just 1. It's just a unity. Anything multiplied by 1 is 1. Pandu into 1 is Pandu. Champa into 1 is Champa. Donkey into 1 is donkey. So that 1 just keeps that thing as it is. So the magnitude, it is not changing. It's only giving me the direction. So this is taking care of the direction, and that is how this eventually becomes the vector quantity. But the problem is this is only in 1 dimension. But what if it is in 2, 3, 4, 5 dimensions? So say for example, I write a number like this. I will use a different color. Say I write a number like this. 3 I cap plus 4 j cap. It means take that I cap and go 3 times. I cap, I cap, I cap, and then again I cap. 3 times. Then 4 j cap. J cap, j cap, j cap 4 times. J cap, j cap, j cap, and then j cap 4 times. Whatever you get is the final vector. This is my final vector. This is now my x component, which is 3 times of I cap. This is my y component, which is 4 times of j cap. 3 I cap and 4 j cap together gives me my original vector back. Is that clear? That is how you represent vectors. The vectors always contain magnitude information in x, y, z directions, and I cap, j cap, k cap point in those directions. They point in those directions. That's how I get the complete information. So I can say my vector is always represented in some x I cap, y j cap, and some z j cap. These are the components. So that is how the vector representation works. Now, if I ask you, what, sir, is the magnitude of this vector? What, sir, is the magnitude of this vector? You might be starting to think, sir, can't I use Pythagoras theorem over here? Absolutely correct. Because this is the base, this is the height, this is 90 degree, this is the hypotenuse. It's obvious that if I take root of base square plus height square, I will get 3 square is nothing but 9, 4 square is 16. So 9 plus 16 is 25. The root of 25 is the number 5. So the magnitude, meaning the length of this vector is 5 units. Yes, absolutely right. So I get an idea that if I'm been given a vector, I just take this number, square of it and put it in the root. So any vector, this should be valid. And what happens is, if you want to find the magnitude of this vector, if somebody wants to find the magnitude of this vector, all you are going to do is inside the root, you are going to take the components, which is Vx square, Vy square, and vz square. That's it. That will give me the magnitude of that particular vector. That will give me the magnitude of that particular vector. Let's take an example. And those of you who are a little bit smart would have visualized one more thing. Sir, this is a cuboid. Sir, this is a diagonal, and I already know the diagonal of a cuboid, formula. I know this from 10th or whatever my basics of geometry. It is the square of the length plus square of the breadth plus square of the height, whole thing inside the root. Length square plus breadth square plus height square inside the root. How many of you can see this? Yes, clear? Perfect. So same way, if I tell, listen bro, I have a vector which says it is 2i cap minus j cap plus 3k cap. Can you figure out what is the magnitude of it? Of course, by my formula, all I have to do is take the component, square it and put it inside the root. So I'll take 2 square. Don't bother over here. This is minus 1 square. It will be 1 square only. Even if you don't take negative sign, it will still be the same. Then 3 square. Do not make this mistake of putting minus and then 1 square. That is wrong. Absolutely incorrect. Negative square will be positive. Okay. So that would be 4 plus 1 plus 9. Right? 9 plus 1, 10. So this will be root of 14. So the answer for this magnitude is root 14. Answer for this magnitude is root 14. Clear? Okay. Let's take one more example coming up on your screen. Okay. Let's take one more example, my dear warriors, coming up on your screen. And here it is. Let's say I give you an example saying, listen, there is a vector A bar and it is I cap plus j cap plus k cap. Is it a unit vector? Is it an unit vector? What do you guys say? Spam the answer in the chat box. Is it an unit vector? Spam the answer in the chat box. Yes, Pritija, this will be a good lecture for covering the backlogs. I'm telling you, this is the best lecture on YouTube. No Hindi, no English, no any language channel would have ever done this, because I know this for a fact. This is exactly what you need for the first 2 chapters of class 12th. Yeah. Is it an unit vector? What do you need to do? The first thing is finding the magnitude and then see whether it is 1 or not. So the magnitude of this, I cap is multiplied with 1, so 1 square, j cap is multiplied with 1, k cap also multiplied with 1. Correct? This is what the formula says. Vx square plus vy square plus vz square, whole thing inside the root, will give me the magnitude of that vector. Okay, so this is nothing but root of 3, which is obviously not equal to 1. So it is not an unit vector. It is not an unit vector for sure. Is that right? Very good, very good. Then if I give you another example which says, listen bro, there is a vector A and it is I cap by root 2 minus j cap by root 2. There is another vector B which is I cap negative by root 3 plus j cap by root 3 minus k cap by root 3. Are they unit vectors? Are they unit vectors is the question. Okay, so let's try and figure this out, whether they are real unit vectors or not. Okay, meaning their magnitude should be 1. Let's start with the first one, A bar mod. So I will get 1 by root 2 whole square. No point taking minus sign, anyways it will get squared, so it will become positive. So 1 by root 2 square is 1 by 2. This is also 1 by 2. Half plus half is the number 1. Root of 1 is 1. So it is a unit vector. It is definitely a unit vector. Let's take this example. This is B vector. Take the mod of it. Okay. So I need to take minus 1 by root 3 square, which is anyways 1 by root 3 square. Again 1 by root 3. All these are the components in X, Y and Z. Square all of them. Square all of them. This is nothing but 1 by 3. This is also 1 by 3. This is also 1 by 3. 1 by 3 plus 1 by 3 plus 1 by 3 is 1. So root of 1 is 1. So definitely it is an unit vector. Got it? How many of you got this as unit vector? Yes, amazing, perfect. So now, till now, you understood how to find the magnitude, how to represent a vector in IJK, what is the meaning of vector, what is the meaning of component, what is the meaning of resolution, what is the meaning of resultant, all of these things. Now, let's say I tell you there are 2 points in 3 dimensions space. This is often the situation even in work power energy, even in center of mass, even in electrostatics, even in sometimes in gravitation. There are some random 2 points. This is 1 point and this is, let's say, the second point. The first point has the coordinates x1, y1, z1. The second point has the coordinates x2, y2, z2. And I want to write the position. I want to write the position of 2 as seen from 1. As seen from 1. Meaning my observer, what is this? My observer is, let's say, here, and I am seeing somebody who is at 2. Maybe this is a Pandu. He is looking at someone. So this Pandu will see at that location 2, and the arrow mark will be directed from 1 to 2. So that is called the position of this particle, this body, this person, this object, whatever it is, as observed or with respect to this particle 1. So the symbol for that is R21. R21. R is always used or generally used for the word position. The word position. So this is nothing but the position of 2 with respect to 1. So in this situation, this 1 becomes the observer, and this 2 becomes the observed. Who are you looking versus who is looking? Getting my point? Now it is also obvious to say this. R12 will be the exact opposite of it, meaning this particle is looking at this particle. So position of 1 with respect to 2. Position of 1 with respect to 2, and it will be exactly opposite. So it will be negative vector of R21. Is that clear? Is that absolutely clear? R12 will be negative of R21. It is opposite in nature. Anyways, that I will keep it aside. I'll just mention it somewhere over here. Not so important. R12 will be negative of R21. Okay. Anyways, now what is the value of R21? This is very, very important. R21, what's the value? The value of that is as follows. The x component will be take x2, take x1 coordinate, subtract the 2 and multiply it with I cap. Meaning it's just as simple as take x2 minus x1 and just put I cap in front of it. That's the x component. Similarly, take the y coordinates y2 minus y1 and just put up the j component, and then finally take the z component, that means z2 minus z1, and just put k cap in front of it. So this is the final vector of 2 with respect to 1. If somebody asks you what's the magnitude of this, that so happens the magnitude of the relative position is also the shortest distance between those points, is also the shortest distance between those points. Think about it. Between this and this, I can go like this, I can go like this, I can go like this, but this is the shortest distance. So that is also the magnitude of it. So R21 bar will be equal to, can you guys guess? This will be nothing but this square, this square, this square. So it will be x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. That is what the magnitude will be. The position vector will be. Yeah, it's like a distance formula. Yes, if you have played with conics coordinate geometry, you already know this is a standard formula of distance, shortest distance between any two points in 3D space, and this is the in generic representation of the relative position in vector form. Okay, so this is the distance formula which we all know, and this is the vector formula. Just to give you an example of this. Just to give you an example of this. Imagine I tell you, Pandu is located at 2, 0, minus 3. Champa is located at 5, 1, minus 4, okay, or we can use some other numbers also, 5, minus 1, plus 4, okay, some random. So what is the position? So the question is, what is the position of Champa? What is the position of Champa as seen by Pandu? So what is the position vector of Champa as seen by Pandu? Pandu is seeing Champa. Don't ask me why. Okay, sir, how do we do this? First, let's write down the notation properly. If I do that properly, my job is done. So who is the observer? Pandu is the observer. Champa is being observed. So my symbol will be, for position it is R. Remember, position is always represented by R. And remember, 2, 1 means 2 is the observed, 1 is the observer. So it will be C and P over here. Position of Champa as seen by Pandu. Always say this in order, you will never make a mistake. Always say this in order, you will never make a mistake. Why Champa and Pandu? Because Champa and Pandu are my regular students. So if you also become regular, maybe I will take your example, also your name also. And I would love to know your names. So next time, maybe in Captos class, you will be an example instead of Pandu and Champa. Okay? Who knows? All right. So where were we? RCP. So what is the formula, guys, for writing it in vector form? Second minus first, second minus first, second minus first, every single time. So second minus first, Champa minus Pandu. So Champa is 5, Pandu is 2 in x coordinate. Always put I cap after that. Then plus, again bracket, Champa minus Pandu, minus 1, minus 0. Then put j cap over here. Then go to third coordinate, z coordinate, 4 minus 3, and this will be nothing but k cap. Is that right? So let's calculate this. This is 3i cap. This is minus 1 j cap and plus 4 minus is plus, no, 4 plus 3 only, k cap. So if you simplify this, this will be 3i cap minus j cap plus 7 k cap. That is the position of Champa and Pandu. Somebody asks, what's the distance between them? Shortest distance between them. It means it is the magnitude of this. So it will be root of 3 square plus 1 square plus 7 square. 3 square is 9, 1 square is 1, 7 square 49, right? So what are we getting? 49, 50, 59. Root 59 will be the answer. Getting it? Very good, Crocs with socks. Shouldn't it be socks with Crocs? No, it should be Crocs with socks. Socks with Crocs. The Croc footwear that you are talking about. Root 59. Very good, Monish. Awesome. What happened to my health? My health is perfectly fine, Pritija. I'm fine. Thank you for asking. Thank you for asking. Yeah, perfect. Great. Now comes the next part of this. If I tell you, listen, bro, there is a vector, okay, there is a vector, fine. I want to find a vector which is in the same direction but of unity length. Getting my point? I want to find a vector in the same direction but of unity length, meaning something like this. So this could be 70 units, this is 1 unit. This could be 15 units, this is 1 unit. So what is the symbol for a unity vector? It is v hat. So while mentioning, I will say v hat is an unit vector in the direction of v bar. In the direction of v bar. What do I, or how do I exactly find this particular quantity? Let me give you an example. Say I tell you, listen, I have a vector which is given by 6 j cap plus 8 k cap. Can you find v hat? Can you find v hat? So first I will think, okay, my vector which is there, my actual vector, that vector is 6 j cap plus 8 k cap. Can I find out what is the value of that? Okay, let's find out the value of it. V bar mod will be 6 square plus 8 square. Now 6 square is 36, 8 square is 64, 36 plus 64 is 100, root of 100 is basically 10. That means this entire thing is 10 units. This entire thing is 10 units. Out of that, I just want a unit. I want a unit, which is v hat. Oh, I know this. This much is 1 unit. This much is 1 unit. This is 10 units. So v hat. How many times will give me v bar? Come on, tell me. V hat. How many times will give me v bar? Obviously 10 times. If I put, I will get v bar, yes or no? V hat, 10 times will give me v bar. So that means my v hat will be whatever is my v bar divided by 10. 1/10 of it is v bar. V hat, sorry. 1/10 of it is nothing but v hat or v cap. Oh, so wait a minute. I know already what is v bar. It is 6 j cap and 8 k cap. And this whole thing divided by 10. That means it is 0.6 j cap and 0.8 k cap. This is my v cap. It means, observe this is v cap. If I go 0.6 units in j cap direction and 0.8 units in k cap direction, I will get a vector whose magnitude is 1 and the direction is same as my original vector. So, my dear students, if I want to find a unity vector in somebody else's direction, take the vector and divide it by this number. What was that number? It's the magnitude. So, that is the reason why we will say v hat is nothing but my original vector divided by the magnitude of it. That will automatically give me my unit vector. Is that clear? Is that clear? So, say for example, I have been given say a vector c bar which is 2i cap minus 4j cap plus let's say k cap or let's say 2k cap. Okay, Chumma, I have taken some random example. Can we find c cap? The question is, can you find unit vector c cap? Well, start with the formula. C cap by the formula is the vector c divided by the magnitude of that vector. Okay, so first let's find the magnitude of that vector, then we will figure out the rest. The magnitude of this vector will be 2 square plus 4 square plus 2 square. Okay, 2 square is 4, 4 square is 16, plus 2 square is again 4. So this will be root of 24. Root 24 means 4 into 6, I can say. Yeah, so it will be 2 root of 6. 2 root of 6, correct? So when I put it over here, I will write 2i cap minus 4j cap plus 2k cap, the whole thing divided by 2 root of 6. Now I can see 2 will cancel. So it will become I cap by root 6 minus 2j cap by root 6 plus k cap by root 6. This is my unity vector. This is my unity vector. Is this clear? Everyone? Very nice. Now, how is this useful for your 12th standard? Let me start with that first. Now, whether it is the chapter of gravity or whether it is the chapter of electrostatics, this is how it works. So, according to Coulomb's law, he says that if you have a charged particle, let's say I call it Q1, and another charged particle, let's say Q2, and there is some kind of distance between them, then they will either attract or repel each other with some force which is called as the Coulomb's force, and this force, if I call it F on 2 due to 1. So what is this? The Coulomb's force, F to 1, is the force on 2 due to 1. Similarly, this will be F12. This will be nothing but F12, which is the force on 1 due to 2. By simple logic, obviously, F21 will be negative of F12. It is the same in magnitude but opposite in direction. Same in magnitude but opposite in what direction? Opposite in direction. Now let's specifically focus on either one of them, because I know magnitude wise they are same, direction wise they are opposite, correct? So we'll talk about it, but before that, Coulomb's law says that this particular force is nothing but given by a number which is 1 by 4 pi epsilon naught. This is the magnitude of the force into product of the charges, upon the separation between them, the square of it. Separation is this, the distance between them, square of it. This number is called as the Coulomb constant. This particular number, what you are seeing over here, is nothing but your Coulomb constant, and the Coulomb constant value is given as 9 into 10 to the power 9 in SI units, which happens to be Newton meter square per Coulomb square. So this is the value of this entire number, by the way. The value of this entire number, 1 by 4 pi epsilon naught, is 9 into 10 to the power 9. Now what is this epsilon naught? Let's not worry about it. For now, just for the sake of it, I'll tell you epsilon naught is nothing but called as permittivity of vacuum or permittivity of free space. It's a number which decides how strong or weak the force will be depending on the medium. Right now we will play with vacuum, but later on you will see if those charges were dipped in some liquid or some solid, then the force will change because of the medium, and this permittivity, this number will change. That's why the force will change. So for now, let's not play with it. Let's just at least understand in free space or in vacuum or even in air, it is almost the same. It doesn't change much. So this is what we'll be dealing with. Okay. So for now, don't focus on epsilon naught. Just think this entire thing is a constant. Okay. Just think this entire thing, 1 by 4 pi epsilon naught K, is basically a constant. Okay, that Coulomb constant is just this. Okay, fair enough till this point? This is what Coulomb says. Don't you remember, this law is very similar to Newton's law of gravitation. Don't you see that this is very, very similar to basically Newton's law of gravity? So if you remember in 11th standard, and if you don't remember also, still I will say Newton's law of gravity, very, very similar. The magnitude of the force is nothing but gravitational constant, and then you have product of the masses, the whole thing divided by the separation square, whole thing divided by the separation square, where you have two masses like this. This is m1, let's say, this is, let's say, m2, and they are now separated by some distance. Now they are separated by some distance, but in case of gravity, the force always has to be attractive, it cannot be repulsive. And this G is then called as the gravitational constant. Gravitational constant. And this gravitational constant has a value of 6.67 into 10 to the power minus 11 Newton meter square per kg square. Okay, that's the unit of it. Anyways, let's not focus much on gravity now. Let's go back to electrostatics. Sir, why did you teach me all these vector concepts? I'll tell you now. Okay, now I'll just tell you. If I have this charge Q1, this charge Q2, I am going to focus only on one of the forces. Let's say this one. This is the separation between them. This is the force on to due to 1. This is the force on to due to 1. Notice how the magnitude will be written. F21 will be, this number is there which is being called as K or Coulomb's constant. I can just write it down as 1 by 4 pi epsilon naught, which is just a pure constant. I'm writing only the magnitude, nothing else. Product of the charges, that means Q1 and Q2. The whole thing divided by distance square. Now the distance, I will write it in a very funny way. Look at it. If I am on 1 and looking at 2, I am finding the force on 2 because of 1. So I am applying a force on 2. So I will look at 2 with respect to 1. So I will write R21. R21 is nothing but a position vector of 2 as seen by 1. Because force on 2 is there because of 1. So I am seeing 2 from 1. So R21 has come over there. Are you able to see that? Yes? Everyone? 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 Okay, fair enough. So, can't you see the separation between them? The separation between them is nothing but the distance formula between them, which means it's the magnitude of this R21 bar. So whatever is the length of this position vector is exactly the separation, and R21 is nothing but the position of 2 with respect to 1. With respect to 1. Oh, so the distance between them is just R21. So a lot of people, instead of putting mod and all this nonsense, they also just write R21, just like in normal vector notations also, right? Over here. Where did we go? If I don't like to put bar and mod and all of that, even if I just put the number A or just put the number OA, it is understood I'm only interested in the magnitude. I'm not focusing on the direction. So sometimes you can skip the mod symbol with the bar because it is extra writing work, nothing else. Other than that, it is the same thing only. Okay. So it's a scalar magnitude. Okay, fine. Coming back over here, just because I'm lazy, you can say, or whatever, I'm not writing bar and mod. It looks very complex and intimidating, scary, fearful. Yes. So R21 square, R21 square, I will just put it over here. That is the magnitude of the force. This is nothing but the magnitude of the force. magnitude of the force. But keep in mind one thing. If I want to find F to 1 bar, then 100% there will be magnitude and there will be a direction, and that direction will be given by a unit vector. A unit vector. Notice the same thing happened even over here when we started discussing all of this. Vector will always have a magnitude and a unit vector which will give me the direction. Yes or no? Correct? So the same thing should happen here. There should be magnitude information and the directional information. So my dear warriors, right over here, the magnitude information we already know, this whole thing, which is 1 by 4 pi epsilon naught, and then q1 is there, q2 is there, and then r21 square is there. What will be the directional unit vector? Just a vector in the same direction but in unity magnitude of unity magnitude. So this will be r21 cap, r21 cap, r21 cap. That will give me the direction. So this becomes my complete force vector. This becomes my complete force vector. This much part is the magnitude part, this much part is the directional part. So this is the magnitude of that vector and this is the direction of the vector. Is that clear, everyone? But we already know whenever we write unit vector, we can always write that vector as the original vector by its magnitude. So that is why we can write this as r21 bar divided by its magnitude, which is r21, which is just r21. So if you do not want to write this and just write it as r21 bar divided by r21, then it so happens that I will have 1 by 4 pi epsilon naught. I will also have charge 1, charge 2 over here. I will also have r21 square. Now notice this and this will multiply. So I will be left with 1 by 4 pi epsilon naught, and then I will have q1, q2 also over here, and then I will have r21 cube. So don't get scared by the cube because this is now a bar. This is r21 bar. So this is also the same thing. It's just a different way of writing. Many kids get confused. Sir, Coulomb's law had inverse square. So how did this become cube? Because this is extra length dimension on the top. Okay. So if you put unity vector, then no need of putting cube. But if you put the value of the cap, which is this bar by the magnitude, this will get multiplied. It will become cube. And that's why it will have this kind of form. So that is why you will see in most of the textbooks, this kind of form is also present. This is also present. Sometimes just this is also present. It is one and the same thing. This is the same thing. This is the same thing. Okay? No difference at all. Can you guess how will the gravitational force law look like? Can you guess how will the gravitational force law look like in vector form? No points to guess this. Come on. F on 2 due to 1. So force on 2 due to 1. First we'll have the magnitude information. Magnitude information means G, mass 1, mass 2 divided by distance square. Okay. What's the distance? Well, I will call this vector from here to here, as R21. This is the position of 2 with respect to 1. So this will have R21 whole square. Lastly, unit vector direction. Okay, if I take a small vector like this, this will be R21 cap, R21 cap. So I'll put R21 cap, but there is a big catch, and that is this is not the entire formula. Can you guess why? Because gravitational force is always attractive. So you will notice one important thing. Position vector is in this direction, R21 cap, but the force is exactly in the opposite direction. So because of the opposite direction, you will deliberately put a minus sign. That is why gravitational formulas you will see in vector notation will have a negative sign. Can you see that why this negative came? The force on 2 is this side, but the position of 2 is that side. So gravitational force is always attractive in nature. Gravitational force is always attractive in nature. Then some students ask this doubt, sir, even electric force can be attractive. Who said it is not attractive? So then should I put a deliberate minus sign here? No need to. Why? Because the sign will be taken care by those two charges. Imagine both the charges are positive, so they will repel each other. So this charge on this charge will apply a repulsive force, so the force direction will come out to be positive. I don't have to break my head. Let's say both the charges are negative, so negative number into negative number is a positive number. So again the force will come out to be positive, and I know as a matter of fact two negative charges will repel, so the force must be repulsive. But one of them is positive, one of them is negative. Then positive into negative is a negative number. So automatically I will get a negative number. The force will become negative, meaning this direction is not right, the opposite direction will be right. So it will be attractive in nature. Why does the same problem not occur in gravitation? Because charge 1 and 2 can be positive or negative, whereas the masses can only be positive. Masses can't be negative or positive. It has to be positive. So you don't have to worry about M1, M2 being negative or positive. Getting my point? M1, M2 is always positive. So this negative always implies it will be attractive in nature. But in electrostatics, depending on Q1, Q2 signs, this force might end up being positive in the direction of R or negatively impacted in the direction of R. R is the positional vector. Is that absolutely clear now, everyone? Okay. So say for example, we have been given the following question. There is a charge Q1 of 6 microcoulomb at 2, 0, -3. There is a charge 2 which is of, I don't know, maybe 12 microcoulomb at some distance of, let's say, 1, -1, I don't know, maybe 1. Find the force vector on 2 due to 1. That is the question. Find the force on 2 due to 1. Okay, ready for it? Shall we find it out? Okay, let's find it out. First, because it's in 3 dimension, it makes sense to use the vector form. So no need of finding the magnitude separately and all of that. So force on 2 due to 1 will be the Coulomb constant 1 by 4 pi epsilon naught, charge 1, charge 2 divided by R21 cube into R21 bar. Okay. Now this value I know is 9 into 10 to the power 9 in SI units. Great. Charge 1 and charge 2. Charge 1 and charge 2. So that is nothing but 6 micro, which is 10 to the power -6. 12. So 12 micro, 10 to the power -6. The whole thing divided by R21 cube and R21 bar. Oh, those are two different things. So what you will do over here, first find R21 bar. So R21 bar will be, remember how do we find relative position? X2 minus X1 I cap, Y2 minus Y1 I J cap, Z2 minus Z1 K cap. So over here it will be 1 minus 2 I cap plus -1 minus 0 J cap plus 1 minus -3 K cap. So it ends up being minus I cap minus J cap plus 4 K cap. Just check this out. So this is R21 bar. So R21 bar mod, which is the distance, will be 1 square plus 1 square plus 4 square under the root, which is 1 plus 1 plus 16 under the root, which is the root of 18, which is 9 into 2, which is 3 root 2, which is nothing but 3 root 2. Till this point, absolutely clear? Okay, very good. Now let's substitute it. R21 magnitude. R21 magnitude is basically this 3 root 2. Everyone till this point absolutely fine. So we will put 3 root 2 and put the cube of it, and R21 bar I'm going to put it over here, which is negative I cap minus j cap plus 4 k cap. Just leave it as it is. Just leave it as it is. Now after that you just have to simplify these numbers. So 9 is there, okay, 6 is there, and 12 is there. 9 minus 6 minus 6. Minus 6 minus 6 is minus 12. 9 minus 12 is minus 3. So 10 to the power minus 3. Then the whole thing divided by 3 cube. So 3 into 3 into 3 and root 2 into root 2 into root 2. Correct? Root 2 into root 2 into root 2. That's what I will get. And this entire vector, negative I cap, negative j cap plus 4k cap. This much part you can simplify later on. Like 3 goes with 9. This also goes with 9. This 3 you can cut with this 12. It will become 4. Yeah, 4 3s are 12. Perfect. And this root 2 into root 2 is 2. 2 goes with 4 2 times. That's all that is remaining. Just check this out. So I will be left out with 6 into 2, which is 12. Here only root 2 is remaining. Okay. And 10 to the power negative 3. And this will be negative I cap minus j cap plus 4k cap. That many newtons. That is the answer. That many newtons. This is what the vector form is. Is this clear? If you want, you can rationalize it and all. That's okay. Till this point, fine. Understood how vectors, unit vector, notation, distance formula, relative position, everything is coming in Coulomb's law. Everything is coming in Coulomb's law. Correct? Now, if 2 or more vectors are there and we have to add or subtract them, it is very straightforward if it is in IJK form. For example, say I have a vector A bar which is 2i cap plus j cap minus k cap, and there is a vector B which is 3i cap plus 7j cap plus 2k cap. And if I am interested in finding out how much is A vector plus B vector when added together, these two vectors can be in two weird directions, and I want to find the resultant of them. And when I am finding the resultant, it means I have some vector A, I have some vector B, and the resultant means something like this. This is the triangle law of vector addition. This is A vector plus B vector, of course. These are your individual vectors, A bar and B bar. But since this is in 3D, you might think it is complicated, but it is not. You just have to add I with I, J with J, and K with K. Meaning, I with I, just add these i's. 2 plus 3 is 5i cap. J plus 7j, it is 8j cap. And this is minus 1 plus 2, which is plus 1, so plus k cap. As simple as that. That's how you can get A vector plus B vector. But let's say I have to find A vector minus B vector. Now when you are to find A vector minus B vector means A vector is as it is, but take the negative of vector B. Take the negative of vector B. This is the negative of vector B. A is as it is, B is negative. Flip B, opposite direction. Then whatever you get, that is basically your A vector minus B vector. That is basically your A vector minus B vector. So A vector minus B vector means just subtract these numbers normally. 2 minus 3, which is minus 1. So minus 1 I cap. 1 minus 7, which is minus 6 j cap. Minus 1 minus 2 is minus 3 k cap. That is A vector minus B vector. Is this absolutely clear, everyone? So when it is in IJK form, there is no problem, only we can directly do the additions and the subtractions. We don't have to break our head. We don't have to break our head. Now the problem comes when it is not in IJK, when it is not in component form. So there are two ways of adding or subtracting them. One is by direct formula. Say for example, I have been told, listen bro, this is A vector, this is B vector. Okay, this is A vector, this is B vector. If I go on the same line of A and I measure this particular angle, this will be the angle between A and B. So then this will be my A vector plus B vector. So let me say I call this vector C. C bar is A bar plus B bar. Now instead of C, I can also call it as the resultant vector. So then the value of this resultant, simply put, can be written down as, take first vector's magnitude, second's magnitude, square them and multiply with 2ab into cos theta. That will immediately give me the resultant vector. Don't have to break your head if a, b and theta are given to me. But let us say I want to find their vector subtraction, meaning this will be minus b bar. Check this out. This will be minus b bar. This will be the vector subtraction. This is the vector subtraction. Subtraction is a vector minus b vector. A vector with negative b vector will be a vector minus b vector. So then the difference is given by similar formula, a square plus b square minus 2ab cos theta. The minus sign comes here, nowhere else, negative 2ab cos theta. This is very useful for quick problem solving. So you should be aware of obviously these formulas, and this was nothing but vector addition using unit notation. Vector addition or subtraction with unit notation. This is how you do it. Okay, vector addition with unit notation. This was using the formula. Example of this, let me give you. They tell you there is a triangle. There is a charge Q, there is a charge 4Q, and there is a charge 2Q over here. It's an equilateral triangle. So this is also A, this is also A, this is also A. And the question is as follows. Find the force on 4Q. Find the force on 4Q. It's an electrostatics problem. That's what I'm trying to do over here. Trying to show you how 11th is related to 12th and why those concepts are so important now. Yeah, observe carefully. On 4Q, this and this both will repel, both are positive. So let me first show you the directions of it. Q on 4Q will apply a force like this. 2Q on 4Q will apply a force like this. So the angle between them, needless to say, since this internal angle is 60 degree, this is exactly opposite of that. So this will be also 60 degree. This will be also, simply put, 60 degree. Okay. Now how much is this force and how much is this force? I can put this as F2. Okay, let's try to find this out. F1 first. Okay, let's try to find F1 first. Magnitude only, no need of direction. Because when we use these formulas, notice A, B, etc. are the magnitudes of vectors A and B. Direction has been already considered in theta. So I'm only interested in the directional aspect, magnitude aspect. So over here, what happens is the F1 value will be nothing but Coulomb's constant, which is, I can put it as K, Q1, Q2, that means 4Q into Q, divided by the distance square, that means A square. So it will be K into 4 and then Q square divided by A square. Is that right? 4K Q square by A square. Similarly, let's try to find what is F2. It will be nothing but Coulomb constant, charge 1, charge 2, that means 4q into q, sorry, my bad, 4q into 2q, 4q into 2q divided by the distance, which is nothing but a square. So that will become 4 2s are 8, 8q square divided by a square. Is that right, everyone? Okay, so I got F1, I have got F2. Now, instead of putting F1, F2 in this entire thing, I have got a trick. I'll tell you what. Just assume this as x. So naturally, this will be 2x. Just assume, just say this is x. Then obviously 8 means it will become 2 times of x. So when I try to find the resultant of these two, this is how the resultant will be. This will be the net force. The net force, which will be the combination of F1 and F2. So whenever I have to find the resultant, which is the combination of two things, I will use this formula now. I will use this formula now. So as I can see, the magnitude will be root of F1 square plus F2 square plus 2F1 F2 cos theta. Great. What is F1? Can you notice F1 is assumed to be x? It will simplify the problem a big deal. F2 is nothing but 2x. So I'll just put 2x and square it plus 2 into x into F2 is again 2x and cos theta, that will be cos of 60. Cos of 60 degrees. So notice x square, x into x is x square will all be common. If I take it outside the root, it will be just x, correct? So here I am left with 1. Here I am left with 2 square, which is 4, plus 2 into 2 cos 60 is basically half. So this will become x, and then 1 plus this 2 and 2 will cancel. 1, 2 will remain. 2 plus 4, 6, 6 plus 1, 7. Is that right? No need of such a big root. This is just 7. But I know what is x. I know what is x. X was 4kq square by a square. So this will be 4kq square divided by a square into root 7. So that is the final answer. 4kq square by a square. 4kq square by a square. Understood how to solve this? Everybody clear till this point? Everybody clear till this point? Pakka? Shall we go ahead? Break already. Already giving up on stamina. So you're in 12th now. Get used to big marathon. 6 hours, 4 hours, 3 hours is like, before 3 hours, if you are asking a break, then you are in 10th standard. Now this concept, that trick which I taught you of assuming a force as x is particularly very useful in many situations. And to show one such more example, but before that, the law of Polygon. The law of Polygon. Imagine I have a force. Imagine I have a force, velocity, displacement, any vector added to another vector, added to another vector, added to another vector, added to another vector. Multiple forces, multiple velocities, multiple displacements, all placed here and there randomly. And I want to find the resultant of them. So it says the resultant of multiple vectors, the resultant of multiple vectors R bar will be simply first vector, second vector, third vector, fourth vector, how many ever vectors are there. So you arrange them in a polygon form, meaning just this. You take any vector, start from any vector. Let's say I start with this vector, then I take this vector, then I feel like, okay, I should take this vector, then I feel like, okay, I should take this vector, then I feel like, okay, I should take this vector or I should place it here. Okay, oops, like this. Just make a polygon. Just ensure head tail order is formed. It should not be like this. This is not right because two tails are together. Don't do that, or don't even do this. This is also not right. Okay, the tail to head, tail to head, tail to head, tail to head, tail to head. That order should be formed. Then start from the starting point, which is the first tail, go to the last head. See, this is head, this is also head, this is also head, the last head. That's it. That will be your resultant vector. You have completed a polygon. You have basically completed a polygon. That is what this law of vector addition in polygon says. Now, sometimes it can also happen, maybe you are having one vector, then second vector, then third vector, then maybe fourth vector, then maybe fifth vector, and then maybe sixth vector, and then maybe seventh vector, like this. You end up at the same point where you started. So if the polygon is closed, if the polygon is closed when arranged with the vectors being added, arranged with vectors being added, then the resultant is 0 or basically a null vector. Null vector in physics is a very special vector. It has 0 magnitude and direction is not defined. Be very, very careful. This is that dot. So that dot over there is a null vector, is nothing but a null vector, and null vector means the magnitude of it is always 0 and direction is meaningless. Direction is not defined. That's the only vector in physics whose direction does not make sense. Okay, this is very important. Now I'll show you how this can play an important role somewhere else. Say for example, find the force on small q at the center. At the center, and this is a hexagon whose side length is A. This is a hexagon whose side length is A. Okay, we'll take a break maybe later on, or maybe not a break. I'll just go with the flow, and we'll be winding up by around 10 o'clock. Okay. Yeah, so we'll be winding up around 10 o'clock. Just 1 hour worth more class. And I'll tell you one thing, when I started my 11th, 12th journey as a JEE teacher, usually I have started with 3-hour classes. When I used to teach online or offline, even then I used to teach for 3 hours, and that was a standard norm in offline also, that the classes will be for 3 hours. Only in online we had this 1.5 hour thing, that too because the screen is in front of you and your eyes need rest. Apart from that, there was no thing like you should end the lecture in 1.5 hour or 1 hour. So in 10th standard till 10th, I think you have those periods where you have classes for what, 35 minutes or 45 minutes max. After 45 minutes, I have seen when I used to teach in foundation, kids used to become so restless, like this they are moving, they are looking here and there. It feels like papa, those kids, no, they have been put in one jail. I have tortured them in Tihar jail and I have put them. That is how that feeling they will give. Looking at their faces only in foundation class, I used to be like, yo papa, after 45 minutes I will give you break, ma, you drink water, go to the toilet, one kid to peed off in the class only after 1 hour. He's like, sir, I can't sit more than 1 hour. Every 1 hour I have to go. I'm like, yo, what is all this? So until 10th standard and all, we do all this. So after 11th, I hope you have better controlling capacities. And by the way, JEE Advanced class, guys, come on. You guys are going to write JEE Mains, JEE Advanced. JEE Mains 3-hour paper. You can't take water break, tea break, dinner break, lunch break. What else is there? Go into the toilet break. No, not allowed. Gone. And JEE Advanced 6-hour class. Yeah, it's a 6-hour test. Yeah, you have a break in between 3 hours, break 3 hours. But imagine on that one single day, 6 hours of, it's like a meditation, it's like a penance, it's like doing tapasya, isn't it? So that is the level where you have to slowly reach. And it also needs to build for one more reason, because if you have those breaks, then your concentration goes, your focus goes, and the same thing will be repeated in the exam. So after 1 hour of solving chemistry, oh, breaks, oh my god, I'm not able to think only of the next question. Again after 1 hour break, so your mind will lose focus. So build the habit of 3 hours. 3 hours is your bare minimum target of sitting continuously for JEE examination. Keep that in mind. That is your biological clock which has to be tuned. Correct? Okay. Why am I solving electrostatic questions, Munish? But I don't know whether you guys saw the, where is this? Where are we? Mechanics for class 12th. So the concepts of vectors, Newton's laws, forces, all of this for class 12th. I am showing you how it is useful for your class 12th. Getting my point? Okay? All right. Now, how do we solve this problem? At the end of the day, this is vectors. That's what I want you to realize. See, learning that concept that, okay, two charges will attract or repel each other with some force, that is just one thing about it. But rest, everything is based on vectors and forces, nothing else. And you will see why. Okay, let's start. Find the force on the charge q at the center. Now, see, multiple forces are there. Multiple forces are there. Let's start one by one. I can already see few of the things just disappearing. I don't know whether you could see that. See, this negative 3q on this q will give an attractive force like this. Correct? And at the same time, that negative 3q on this same charge will give the same attractive force. So won't it basically cancel out each other? Won't it basically cancel out each other kind of? Okay. This charge q on this charge q will give a repulsive force. Will give a repulsive force. Will give a repulsive force like this. Will give a repulsive force like this. So if I call that force as x, and I'll tell you why I'm calling that as x. Because every other charge is a multiple of small q. So look at that x, or if you want to call it as f only. Okay, if you want to call it f, you can call it f, or you can just call it x, it doesn't matter. Okay, so x is the force on the charge which is at the center due to this charge over here, due to q. So how much will that x be? Check this out. It will be Coulomb constant, charge 1, charge 2 divided by this distance. Now there is a special property of a hexagon. What is the special property of a hexagon, guys? There are like 6 triangles which are formed. Yes or no? 6 triangles which are formed. So in a hexagon like this, you get basically 6 triangles like this. You join, okay, diagonals like this. Join all the diagonals like this. You get 6 equilateral triangles, isn't it? 6 equilateral triangles. That means if this is A, 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 naturally this side is also A, this 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 is also A. Not just that, each of these angles over here that you are seeing is also 60 degree, 60, 60, 60, 60 and 60 and so on and so forth. Yeah, that's the property of a standard regular hexagon. So use those properties and you will solve this problem within seconds. I'm explaining this in detail, so mind it. Okay, so what is the distance between this charge and this charge? It's basically this distance, which is nothing but A. So I'll put A square over here. Okay, I put Q square by mistake. Okay, so this will become K Q square divided by A square. K Q square divided by A square is the force between Q and small q. Now think naturally, the force between this Q and this 3Q will be how many times? One charge will be Q, other charge will be 3Q. So it will be 3 times of X. So won't this be 3X? This will be also 3X. But, what is that but? But 3X and 3X will cancel because they are in opposite directions. They are in opposite directions. This and this will 100% cancel. Perfect? Okay. This is X. How much will this charge apply on this Q? The charge magnitude is double. So if I write the formula for Coulomb force, K into 2Q into Q divided by A square, that means it will be double of X. So this negative charge will give an attractive force, and that attractive force, needless to say, will be 2 times of X. Will be how many times of X? 2 times of X. Pakka? Okay? Clear? Alright. Now, let's talk about this 2Q and this 4Q. Can you guess how much this charge will apply on this charge? Q into 2Q. That means the number 2 will be extra. So that means a 2x force repulsive. 2Q on Q will be repulsive force of 2x. This 4Q on Q, what will be the force? K, Q, 4Q by A square. So 4 will come. That means this charge on this charge will apply a repulsive force of basically 4x. 4x. Now look at all these forces. Out of that, this 3x and this 3x cancelled off. That 3x and this 3x cancelled off. So on that charge Q, what are the forces which are remaining? This x and this 2x, obviously. This x is remaining and this 2x is remaining. So together, how much will it be, guys? This x plus 2x, won't it be 3x? Everybody gets this? This x and 2x together will be 3x. Everybody understands this till this point? Okay, next. This is 4x, this is 2x. So 4x is here, 2x is here. How much will be the balance? Spam the answer in the chat box. Come on, everybody need to wake up. How much will be the balance? 4x force is here, 2x force is there. How much is the remainder force and in which direction? Obviously 4x is this side, 2x is that side. So 4x minus 2x, how much is the remainder? 2x in this direction. So won't I get a force of just 2x, which has basically come from 4x minus 2x in this direction? Everybody till this point absolutely clear? Now can you also guess how much is the angle between these two? Can you guess what is the angle between these two? Yeah, the angle between this and this, meaning the angle between this and this. 60 plus 60, how much is it? 120. This is basically 120 degrees. 120 degrees. Now you have one force, another force and angle. Finding the resultant is not a big deal at all. Yes, the resultant force. The resultant force. So the resultant force will be root of first force, which is 2x, second force, which is 3x, plus 2 times 2x into 3x into cos 120 degrees. A square plus b square plus 2ab cos theta. Okay. So F will be x square is common. So x goes outside. The root 2 square is 4, 3 square is 9 plus 2 into 2 into 3 into cos 120 is minus half. Just put it over here, is equal to x, the whole root 4 plus 9. Okay, first before that 2 and 2 will cancel, 2 3s are 6, so minus 6 will be there. So 4 plus 9 minus 6 will be there. So it will become x root, how much will be there? 9 minus 6 is 3, 3 plus 4 is 7. So x root 7, and how much was x? We assumed x as something kq square by a square. So it will become kq square by a square root 7. That is the net force on the charge q. Understood how we solved it using the logic of vector addition? Only Coulomb's law, the 12th standard concept was only this much. What is the force between two charges and whether it is attractive or repulsive. After that, there was literally nothing. After that, there was literally nothing. Is that clear, everyone? Yep. Cool. Very nice. Very nice. How to develop out of the box thinking? Shall I ask you a puzzle, guys? Ready for a puzzle? Can I ask you guys a puzzle? Can I ask you guys a puzzle? Yeah, put some fire emoji on the chat box. Out of the box thinking, isn't it? Ready? Pakka? Yes? Okay. Here we go. You have 12 matchsticks. 12 matchsticks. Everybody knows a matchstick, something like this. Okay, like that. You have basically into 12. Using them, make 6 squares of same size, and obviously no breaking those matchsticks. No breaking those matchsticks. Make 6 squares of the same size. Okay, come on. Let's see how many of you can do this. And you can type out the answer. I know you will be like, sir, how do I show it to you? The answer is so simple that you can type it out. That's your clue now. Okay, you can easily type it out. Come on. You have to make 6 squares. You have to make 6 squares using 12 matchsticks. How on earth can you do that? Anybody got it? Put a thumbs up. Just try it out on your piece of paper. If you got it, 100% you can post the answer as a line on the chats. As a line on the chats. Yes, anyone? Nobody? Too difficult? Once I tell you the answer, you will be like, oh my god, sir, what is this? I could have thought about it. Okay, no issues. I will show it to you. Make a cube. Make a cube, guys. In a cube, how many edges are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Those are your 12 matchsticks. And how many faces are there? 6 faces. So you got 6 congruent or equal squares. Simple. It was a 3-dimensional figure. Got it? How many of you understood this? Pakka? Great, amazing, isn't it? You just had to take a cube. Who asked you to make it in 2 dimension? I never constrained you that it has to be in 2 dimension. That is out of the box thinking. When you solve puzzles, when you solve more puzzles, that's what happens. That is called lateral thinking, creative thinking, out of the box thinking. And one simple thing about lateral thinking or out of the box thinking is always about a joke. If you see, most of the jokes, not all kinds of jokes, most of the jokes are usually lateral thinking. What is a joke at the end of the day? You think normally. So one person thinks in a very different way, which nobody thinks about, and you find it funny. That's basically a joke in mathematical terms, isn't it? So it's the same thing. So if you are good at jokes, if you are funny, you should be good at lateral thinking anyways. But this is not the only solution. That's the best part. See, that is what, making a joke over a joke is. Somebody cracks a joke and you have a counter joke and you make it very funny, but don't kill the joke. So what is the another solution to this problem? There is one more solution. Okay, you can make a cube. The other solution is, I make a square. What do? I make a square. Okay, this was just one of the solutions. I'll just... How many matchsticks got used out of the 12 matchsticks? 1, 2, 3, 4. 4 matchsticks got used. Perfect, no issues. Now I'll take 2 more matchsticks. So 4 plus 2 is 6. But I will put them here. I will put them here like this. Perfect. Okay, very nice, sir. So 4 plus 2 is 6. 6 more are remaining. No issue. Now what I will do, I will take those 6 matchsticks and put it like this. 1, 2, 3, 4, 5, and like this. What did I just do? What did I just do? What is this number? Yeah, this is the number 6. That's it. This is the number 6, guys. So a square into 6 is 6 equal squares. Done. Getting my point? This is just a square multiplication symbol into 6. 6 equal squares. How many of you blown out of your minds? How many of you blown out of your minds? Blown out already? Yes, sir. This is crazy, amazing, loving it. Yeah? Very nice. Great. Good. All right. So now let's go to the next thing, where you will see whether it is Newton's laws, whether it is vectors, whether it is projectile motion, this resolution comes. And you will see that it is also going to come in electromagnetism and so many other places. So when we have to find the components, when it is not given in I cap j cap, you have to make I cap j cap, what do you do? So say for example, I have been given a vector and I have been just told that, bro, listen, it just makes some angle out here, and that angle which it makes is, let's say, theta, and let's say this vector is v. And I am interested in figuring out the components of it. One of this is here, the other one is perpendicular to it. So it so happens that the component which is closer to theta, see, there are 2 components, this one and this one. This is closer adjacent to theta. Close, cos, C-O-S, close cos. It's closer, it's cos. So it will be V into cos theta, as simple as that. C-L-O-S-E, C-O-S, cos. Got it? Simple. If you are far away, by going far away, you commit a sin. You commit a sin. Chumma, I'm not saying this is reality or these are some of those 10 commandments given. Okay, but yeah, you commit a sin. Okay, so you have committed a sin. So sin, if you remember that, that's it. So as you can see, this component is far away, so it has committed a sin. So it is V sine theta. If you know this, you are sorted, done and dusted. Nothing more, nothing less. Arijit, what is this? What is this means? This is this only. That is how that this is. And if you think like this, then only you can think out of the box. And then only you will become more creative, you will become more successful. Okay? So, you asked me a puzzle, I gave you a puzzle. I have a list of puzzles, but not everything can be taken today. So, let's say for example, random vectors I will draw. And let's give them some magnitudes, 10, 20, 30, 40, 50. Let's give them some direction in life. Okay, 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 okay. And let me mark the angles. 20 degrees, 30 degrees, 40 degrees, 60 degrees, 70 degrees. Chumma, some random angles I have marked. Now let me see what those components are on the next slide. I just mentioned to you, whenever you want to make components, just split the vector into two perpendicular directions always, and the closer is cos, the farther is sine. So when I want to split 10, I'll open it up like this. So you will, oh my gosh. This is one component, this is another component. This is one component, this is another component. This is one component, this is another component. This is one component and this is another component. This is one component and this is another component. Okay, so first open it up, split it. Okay, that splitting is very easy. You can easily guess. If I'm moving here, that means I'm moving west and south. Here, west and south. This is north and east. This is east and south. This is negative x and positive y, or west and north. Once you get that, you just have to write those numbers. Observe. This is 10, this is 20. So this is 10 cos of 20. 10 because this is closer. This is far away. So this will be 10 sine of 20. This will be 20 cos 30. This is far away, so this will be 20 sine of 30. Similarly over here, this is closer, so 40 cos of 60. This is far away, so this will be 40 sine of 60. This is closer, so this will be 30 cos 40. This is far away, so this will be 30 sine 40. This is closer, so that's why it will be 50 cos 70. This is far away, so this will be 50 sine 70. Everybody fine till this point? Cos sine, cos sine, cos sine, cos sine, cos sine. Okay, great. Sir, can I get IIT with 102 marks in this year's IIT with 102 marks? Little bit on the danger side only, man. It's little bit on the danger side. I am not really sure. So this is how you take the components. Now, let's say for example, when you have those inclined planes, you often get those components and you often show the forces acting on the masses. And this is one common pain point area. When you have these forces, sometimes pseudo forces there, tension, spring, God knows, 100 forces are there. And then this is mentioned that this is, listen, this is angle theta, this is angle theta, okay. And we are interested in finding out the forces, components, blah, 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 100 things are there. So often people get confused, when is mg cos coming, when is mg sin coming, all of those tensions come in your head. So don't worry, I'll tell you what to do. See, first, draw the horizontal and the vertical. Horizontal, vertical. Next, show the inclined and the perpendicular to the incline. Incline and perpendicular to the incline. Once you have these 8 lines or 8 partitions, I would say, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so you have 8 lines, or you can say 8 regions. 1, 2, 3, 4, 5, 6, 7, 8. 8 regions. That's it, your job is done. What was this theta measuring with? Incline and horizontal. This is horizontal, this is incline. Just mark that angle as theta. Just mark this particular angle as theta. Leave the next region, jump to the next region. This has to be theta. Leave this region and jump to the next region. That has to be theta. Leave the next region, jump to the next region. That has to be theta. Leave the region next, it is back to theta. So every alternate region is theta. Everybody got this? So what am I saying, guys? What did Shreyas Sir say? What did Shreyas Sir say? Shreyas Sir said divide it into 8 regions and automatically you will see all these angles. All these angles are basically equal. All these angles are basically equal. Okay. Now it becomes very simple to resolve or split anything. Let's say my force of mg is here. Mg is the weight of the object. Let's say my normal force is here. Okay. Normal is the reaction force by any surface. Let's say my friction is acting in this direction. Okay. Let's say there is some another force, maybe pseudo force or spring force or tension force or some pulling force in this direction. So let's say this is my pulling force. Let's say this is normal force. Let's say this is frictional force. Let's say this is the weight or mg force. All are different forces. And if I wanted to split them, it is now so easy in case if I wanted to. For example, if I want to split weight into 2 components, I can already see the 2 components right over here. One is like this, the other is like this. Can you see that? This, I am splitting it into 2 perpendicular directions. Since this is closer to theta, close cos, so this will be W cos theta. This is far away from theta, so this will be W sin theta or mg sin theta. Understood? This is far away from theta. Similarly, let's say I wanted to split P. I wanted to split P. P is here. I can split one like this and the other one like this. Since this component of P, I have split it into perpendicular directions. This is closer to theta. That's why this will be P cos theta. This is far away from theta. That's why it will be P sin theta. Notice how the directions are the same, but one is a sine component, the other is a cos component. So a lot of people by heart, sir, this is cos direction, this is sine direction, blah, blah, blah. Nothing like that. Check whether it is closer or far away from the angle from which you are resolving or splitting. Okay. Now, once you do this, you might be wondering, sir, why are you not splitting normal and friction? There is no need to do that. See, once I split a force into its components, there is no need only of that force. It's already been taken care of because these 2 forces together will make up the resultant force, number 1. Number 2, can you see all the forces are in perpendicular directions? This force is here, this force is here, this force is here, this is here, this is here, this is here. That's it. You don't have to break your head after this. You don't have to do anything after this. You don't have to split friction or normal, because splitting friction will further involve more complications. You should, at the end, in a 2-dimensional problem, only have 2 directional components. One like this, one like this, or one like this and one like this. Basically 2 perpendicular directions only. That's it. If you notice, here also, most of the 2D problems we are doing that only. Here also we just got 2 forces and then we are trying to find the resultant. Anyways, coming back over here, once I know this, these are the components of the forces. They are playing the same role as the original force. So if I had W instead of these two, it's the same thing. If I had P cos and P sin instead of this, it's the same thing. Okay. Now comes something called as the Newton's law. Now what does Newton's law say? Newton's law says that if you have the sum of forces, this is the vector sum of the forces, vector sum of the forces, that is equal to the mass times the acceleration, mass times the acceleration of that body, mass times the acceleration of the body. Okay, great. So if you go back over here, you will notice there is one force here, and a friction here. Maybe this particular body was accelerating in this direction. It's going to fall down like this. It's going to go down like this. So notice the net force must be also in the direction of acceleration. I can't say my acceleration is here and my force is there. How is it possible? I am applying, pushing it there, but it is coming this way, accelerating this way. Not possible. If I am pushing in that direction, the acceleration should be also in the same direction, which means this must be the direction of the net force. So these two forces minus this friction will give me the resultant force. Forget these forces, will give me the resultant force in this direction. So if I go along the incline, the incline direction, I will say P cos theta with W sin theta, but F is opposite, is my net force. This is my net force, same net force over here, will be mass into acceleration, which means it will be m into my A. M into my A. M is the mass of that particular object. It could be some value m. So this is my equation of Newton's law that I will write. This is the equation of Newton's law that I will write. Sir, what means normal force, friction force? Okay, I will explain that also in a bit. Hold on 1 second. For now, just assume normal is a force, friction is a force. What is that force? I will tell you in a bit. Okay. Now, just like I wrote an equation along the incline, I can also write perpendicular to the incline. Perpendicular to the incline. Perpendicular to the incline. Can you see this and this together? And this is opposite, but there is no acceleration. This body is only going like this. It has no motion like this. It is not going like that. It's just going like this. So there is no motion only in this direction. So I can say my normal plus P sine theta, normal and P sine theta together, but W cos theta is opposing it. So minus W cos theta will be mass of the body into acceleration, but guess what? Acceleration is 0. Acceleration is not there only in that direction. So I can also say, therefore, normal plus P sine theta, take this on the other side, is the W cos theta. So this and this together is balancing W cos theta. It's not having any resultant force over there. So the resultant was 0. So this net force is 0, and hence there was no acceleration. No acceleration. There was no acceleration in that direction. Did you understand how vectors are playing a role in Newton's laws also, and how Newton's laws will also come now in electrostatics and everywhere else? Correct? Okay, now what is this friction, sir? What is this normal, sir? This is one common doubt which many kids have. Okay, see, imagine this. There is a surface, there is a block, and I am trying to push it. I'll just show it to you. Wow, educators to receive free monthly newsletter, register for an educator account. I think I should register. Okay, anyways, just hold on a second. Now I can explain the entire Newton's laws right from here. Okay, it's a very beautiful simulation, and it will make you understand a lot of things. Imagine there is this dude, there is this block, and this surface is smooth. The friction is not there at all. Okay, I can also have a speedometer with the values on it, so I can see how the speed is changing or not changing. So let me apply a force of some newtons and see what is exactly happening. Okay, I have applied 60 Newton, whatever, 50 Newton force. Chumma, can you see the speed is increasing? A force causes motion's change. If it was at rest, it came into motion. If it was in motion, then I can bring it to rest. I can end up changing the direction also using the force. So it stopped and changed the direction. So force is the reason, is the cause of the motion. That's very obvious from here. And this force can change the motion and can cause the speed to change, means it causes acceleration. So force causes this acceleration of a body. This is actually Newton's second law in a different way. I have explained it. Okay, so actually the law is force causes changes in the momentum, but it's another way of looking at it. Force causes acceleration. The actual law is force causes rate of change of momentum. So I can see the momentum is continuously increasing, changing. So force is causing change of momentum. Now let me stop applying the force. That dude just vanished. Look at the speed. The momentum will not change. Can you see that? The momentum will not change. That is Newton's first law. When the forces are not there or they are balanced. Right now there is weight and all of that, but it is being balanced by the ground force. So total force on it is 0. There is no force on it. The sum of the forces is 0. Then the body maintains its state of motion or of rest. If it was at rest, it will continue, but this is in motion. It will continue endlessly until there is an external unbalanced force. So if there is an unbalanced force, it will 100% change its motion. You can see the speed is reducing. But the moment that goes off, again it will maintain its new state of continued motion. Now if there is friction, obviously there is an unbalance, and because of that unbalance you will see the speed will reduce, unless somebody decides, wait a minute, I will also apply an equal amount of force. Look at it, 75, 75. I am pushing it as much as it is being resisted by this rough surface. That rough surface gives something called as friction. Friction comes between any two surfaces. You cannot probably get smooth surface no matter how much you polish them. There is always some kind of discrepancy, some peaks, valleys, some kind of forces between two surfaces. So that is friction. If it is too rough, more friction. If it is too smooth, less friction, but not zero. Zero is only ideal. Now can you see there are forces, but they are balanced forces. The moment the forces are balanced, the body maintains its state of rest or of uniform motion. That is Newton's first law. Is that clear, everyone? Monish, Kritija, Pops, IIT, Damin, Mr. Home, Rushil, everybody. Suk, Arjit, Vinay, My Staries, Animes, yeah, Vinayak, everybody. Newton's law is clear. What is the meaning of Newton's law? Yeah. So now, if you go to this particular question, where was it? This particular question, there were multiple forces on it, but this box was accelerating. That means there was an unbalance. But since it was accelerating like this, that means the unbalance was in this direction. It was not balanced in this direction. But this direction, it was balanced because it was not having any motion like this. So when I saw all the forces on it, I concluded this force and this force together will be balancing n plus p sine theta minus w cos theta will balance. That means they are equal. But in this direction, they are unbalanced. So it is accelerating. So these two must be the larger forces as compared to F. That's why I wrote P cos plus W sine minus F is equal to MA. Because somebody will be like, sir, why did you not write F minus P cos minus W sine? In that case, if I write F minus something, meaning this force is larger than these two forces, which can't be the case because I know for a fact that it is going down like this or accelerating like this. So that is why these two combined together minus this will be positive, like that. Got it? Everyone clear? Pakka? Amazing. So speaking of which, what is friction? Normal. Whenever two surfaces are in contact, if you zoom onto them, you will see the surfaces will be somewhat like this. The surfaces will be somewhat like this. There will be electromagnetic forces at minute level. So you will see that this surface below on this surface will apply forces like this at different places. Like this teeny mini electromagnetic forces. So if I take all these teeny mini electromagnetic forces, this chintu mintu electromagnetic forces, and if I take the resultant of all of them, if I take the resultant of all of them, this resultant is called as the contact force because they are two surfaces in contact. So that is called as the contact force. What is it called? It is called as the contact force. Whenever two surfaces are in contact, there is electromagnetic forces between them. These are electromagnetic forces due to contact, and you will see there will be a resultant. So this contact force is a resultant of all the electromagnetic forces due to the contact. If you take a component of this contact force parallel to the surface and another component perpendicular to the surface, so there are two components, not in horizontal or vertical, because this surface only can be tilted. Okay, so don't get me wrong. A lot of people think this is horizontal, this is vertical. No. This is in this specific diagram, but I take the component parallel to the surface and a component perpendicular to the surface. Perpendicular, the other word for that orthogonal, other word for that normal. So I call that as N, which is normal force. Normal means it is basically perpendicular. This component which is parallel, that is F, which is then called friction. It is called friction. Is that okay now, everyone? What is the meaning of normal? So whenever any two surfaces touch, there is automatically a normal. Friction may be there, may not be there, it depends. But if it is there, it will always be parallel to the surface. So if there is a scenario where you have a block and you have a surface, and it so happens that there is only normal is there, and that is the total contact force, but the friction is not there, then it will be basically a smooth surface. It will be basically a smooth surface, or basically no friction acts. No friction acts. In that case, the entire normal and the contact force are exactly identical. There is no friction at all. They are exactly the same. There is no component in that case. Does friction exist for quantum particles? It's not like that. It is a macroscopic property than a microscopic property. So it generally comes for two big surfaces. So then you can ask, sir, will two protons ever rub and have friction? That's a very good question. Forget subatomic part, forget quantum particles. I will say whether protons touching each other have friction against each other. It's a very good question. Think about it. The problem is two protons, very, very difficult to touch. They will have so strong repulsion when they come so close. And the protons are very small particles. And when they touch and you're saying, I'm going to rub them against, it's almost near to impossible to conduct that experiment also and to figure out whether there is friction. Okay. So at that level, identifying where it goes into a quantum zone, it's another a different topic only. So finding the location of quantum particle is difficult, because then if you are moving it, then it has momentum, and then there is Heisenberg uncertainty principle, which says that if you know the location, you can't find the momentum, and if you know the momentum, you can't find the location accurately. So it becomes a very big dilemma. Okay, cool, understood? Awesome, awesome, great. Yeah. Does electric current experience friction? When current flows, charges, basically electrons flow, then it is not that it is rubbing against the material. The resistance that current encounters is not because of friction, but it is because of the collisions. It's because of the collisions, electromagnetic forces. So it is not really friction. So friction is more of a macroscopic property. Got it? Okay, great, perfect. So that was about this Newton's law over here and how it is useful. You will see even in electromagnetism and all of that. Okay, great. So I think we have done quite a big deal. Anything else? Anything else you want me to explain before I conclude? In the next class, maybe I can do work energy, more of circular motion related concepts, and a little bit more of Newton's laws and all of that. Yeah. You want me to explain anything else? Please let me know. Else I am done for today. Sir, I am starting from the basics by watching the lecture and practicing PYQs. Is that enough to cover backlogs? Yes, watch the lecture, but don't directly jump to PYQs. Please solve the basic questions, DPPs, solved examples, class examples, and then jump to exercise questions and then jump to PYQs. That's the right order. Okay. All right, great, cool. That's it. I hope you enjoyed the class. I hope you loved the class. And like I said, you need to have that schedule of sitting for 3 hours. Okay. Number 2, like I said in this quote today, please don't force yourself to make your mind for it rather than, just forcing yourself. Yeah, force can cause acceleration, but force can't make you to study. So you have to convince yourself why you are studying. If you are convinced, then no matter what happens outside, trust me, you will be focused on your studies. Else, somebody is pulling you, somebody is pushing you, you will watch 100 strategy videos, it will not help. But you are now convinced, you know why you have to complete the backlogs. You can see now, just from this lecture alone, how many vectors, Newton's laws, resolution, force concepts are coming up in the chapter of electromagnetism or electrostatics. So you can see the importance of 11th. And imagine doing all of this after November, when your syllabus is done of 12th, you barely have few days. And after a month, you will have JEE Main's first attempt. So that time you don't have the time. And even if you could try and complete 11th, it will be all half-baked. So better to start now. If you were getting 7 hours, to study, make it what? Sir, now I'll study for 5 hours of 12th, 2 hours for 11th. Wrong. If you're getting 7 hours to study, keep that 7 hours, find extra 2 hours and give those extra 2 hours for 11th standard. Got it? That is how you're going to complete your backlogs. You cannot make the earth rotate slower and say, I will make 24 hours, 26 hours, that's how I get extra 2 hours time. For the toppers, for you, for the last ranker, the time of the day is simple. 1 day, 24 hours. It's neither more nor less. Everybody gets the same thing. It's up to you how you're going to use that time. Alright? Thank you so much. This was Captain Shreyas. Have a great time. Love you all. And my warriors, please, please, please come on war footing and fight it like a true warrior. Bye bye. Take care. Hasta la vista.